Welcome to another episode of our multiplayer survival game online course in Unreal Engine 5.5. In this tutorial, we'll dive into building the storage box, which will be a key feature in our multiplayer survival game. The process might feel a bit overwhelming at first, since we'll be working across multiple blueprints, but once the box is complete, we'll go back and review everything to ensure it all makes sense. Stick with me until the end, and let's begin. For the storage box, we'll start by setting up its mesh. Begin by navigating to the Inventory System folder and creating a new subfolder named Mesh. Open this folder to prepare for importing assets. For this project, I'm using a free asset from the Fab Marketplace. If you'd like to follow along with the exact asset, search for Woodbox in the Marketplace. Download the fbx_woodbox.zip file and extract its contents. Once the files are extracted, drag the folder directly into the Mesh folder in Unreal Engine. When the import dialog appears, click Import to bring the asset into your project. Open the Woodbox folder, then navigate to the Source folder. Here, you'll find the static mesh and its associated material. Open the material file to customize its setup. Inside the material editor, remove all existing nodes except for the material node. This will simplify the graph and allow you to set up the textures effectively. From the content drawer, navigate to Inventory System, Mesh, Woodbox, Textures, select all 5 texture files and drag them into the material graph. Arrange the nodes neatly and connect them as follows. Link the base color texture to the base color input, the ambient occlusion texture to the ambient occlusion input, the normal texture to the normal input, the roughness texture to the roughness input, and the metallic texture to the metallic input. Once connected, adjust the layout for better readability. Then click Apply and save the material. When you open the static mesh in Unreal Engine, you should see the textured storage box. With this, our initial setup is complete, and we can proceed to the next steps in building the storage box system. Open the Inventory System folder and create a new Blueprint class. To do this, right-click within the folder, select Blueprint class, and choose Actor as the parent class. An actor is an object that can be placed or spawned in the world, which is exactly what we need for our storage box. Name the blueprint BP_storage_box and then open it. The first step is to add a static mesh component to represent the box visually. In the Components panel, click the +Add button in the upper left and search for static mesh. Add this component, and with it selected, go to the Details panel on the right. Locate the static mesh property and search for the Woodbox static mesh we previously imported. Select it, and you'll see the visual representation of the storage box appear in the viewport. This is the object we'll later place in the world. Next, we need to add the inventory functionality. For this, add a BPC inventory component to the blueprint. This component will handle the storage logic. After adding it, rename the component to Storage Inventory to make its purpose clear and specific to the storage box. With the components in place, switch to the event graph, where we'll start building the logic to make our storage box functional. Delete the default events in the event graph of your BP storage box, as these won't be needed for now. Instead, we'll create an interface to handle interactions for the storage box. Go to the Inventory System, Interface folder, right-click, and create a new interface. Name it BPI_interact. This interface will define the interaction logic for the storage box and allow communication between blueprints. Open the newly created BPI interface and add 3 functions. The first function is named Interact. Add an input parameter called character_ref and set its data type to BP third-person character as an object reference. This function will handle interactions initiated by the player character. The next function is called stop_interact. Similarly, add an input parameter named character_ref and set its data type to BP third-person character as an object reference. This function will handle when the interaction ends. The final function is named getWidget. Add an output parameter called widget and set its data type to userWidget as an object reference. Once you've added these functions, save and close the interface. It's now ready to be used in the BP StorageBox and other blueprints that require interaction capabilities. We will now add the interface to our StorageBox under the class settings. Click on Implemented Interfaces, select Add, and choose the BEPI Interact interface. Compile and save it. This setup allows us to define and utilize custom interaction behaviors for the StorageBox. Bring both interface functions into the graph by double-clicking on them. This ensures we have placeholders for the interaction logic. Then, create a custom event named Character Access Storage Server. Change its replicates property to run on server and check the reliable checkbox. This ensures the event is executed on the server side in a networked game environment, maintaining synchronization across clients. Next, create a variable named accessing characters. Set its data type to BP third-person character blueprint as an object reference, and make this variable an array. This array will hold references to all characters currently accessing the StorageBox. Drag this variable into the graph and search for the addUnique node. The addUnique node ensures that duplicate entries are not added to the array, maintaining a clean list of unique characters. Connect the execution pin of the custom event to the addUnique node. Take the array add pin and drag it onto the event. This will automatically create an input pin. Rename this pin to character_ref. This pin represents the character attempting to access the StorageBox. Drag the storage inventory component into the graph and position it nearby. We will use this component later for inventory-related actions. Drag the accessing characters variable into the stop_interact interface and add the remove item node. Connect the execution pin and the character_ref pin to the remove node. Duplicate the storage inventory variable node and position it near the stop_interact logic for clarity. Select the character access storage server event, highlight it, and add the comment, register player to access the storage. Similarly, select the stop_interact event and comment it as stop player accessing this storage. Next, connect the execution pin from the interact event to the character access storage server event and link the relevant character_ref pin. Drag the character_ref pin from the interact event and search for the getController node. Since we need to trigger an interface function on the player controller to manage the widget and the interaction logic for our storage actor, we will create this interface now. Open the BPI player controller interface and add a new function named accessActor. This function should include an input parameter named actor with the data type actor object reference. Save the changes and return to the storage blueprint. Use the return value from the getController node to call the newly created accessActor interface function. Bind the actor pin to the self-reference, ensuring that the player controller correctly identifies the StorageBox. Highlight this section and add a comment labeled Start Interact. Compile and save your work, then return to the map overview. Drag and drop the StorageBox into the level and place 3 instances for testing interaction capabilities. At this point, we'll conclude the episode. In the next episode, we will rework the inventory component to optimize data replication. This improvement will ensure that data updates are sent only to players actively interacting with the storage box, avoiding unnecessary network traffic for others. If you've enjoyed the tutorial so far, consider leaving a like or subscribing to stay updated for the next episode. Quick announcement. I'm currently developing a comprehensive course where you'll learn how to build a complete survival game from scratch, all the way to publishing. It will feature a wide range of functionalities, and I'll be sharing more details soon. Thanks for watching, and see you in the next episode.